MongoDB is a NoSQL database. So NoSQL databases do sharding natively. There's no exception to MongoDB. So MongoDB does sharding. Sharding is about splitting a large database into smaller databases, right? Smaller pieces. Then we put each piece on a node. So that's how we do distributed data storage and distributed data processing. So you look at the diagram I'm sharing now. So we have a database split into many pieces, many smaller databases. And each database, each smaller part, each piece is a shard. So we have many, many shards. Then to our applications, to our users, they see only just one big database. So they see just one big virtual database, one big virtual server, right? But actually, we have a cluster. Within the cluster, we have many nodes. On each node, we have a small database or a piece of a big database. Our applications and our users will work through the driver. So the driver makes them think there's just one database and one server. But the driver has many, many helps from other underlying components, for example, a query router, right? So we don't need to worry about this part, the driver and the query router. And our users are not even aware of how many servers we have, right? Or how many smaller databases we have. They see only one big database and one virtual server. So that's the architecture of MongoDB. And this is how we can do scale out, horizontal scalability. We scale out, right, transparently. So very, very beneficial.
Professor, can you go back to the previous?
Sure, yeah.
Here there are many databases, right? Every database will have all the data, or it will have different data, like segregate.
Yeah, it's a great question. So we are talking about sharding here. So when we do sharding, you can think about each shard is part of a database. So depending on the architecture, sometimes it's just part of the database file. Sometimes it's just a smaller database. So depending on the implementation, but simply speaking, each shard is just part of a big database. For example, if we have a very large database and we shard it into 10 pieces, right? Then each shard is 10% of the database, generally speaking. So
Okay.
we are talking about sharding them. These are pieces of a big database. They are not a copy of each of the complete database, just a piece.
Professor?
Okay.
Yes.
So is sharding same as the Hive partitioning?
Yes. We use partitioning to do sharding. So I think let's talk about partitioning here. So sharding is partitioning. So that there's just different words, different terms, right? So when we do sharding, we do partitioning, and we say each of these is a partition, right? We can also say we have shard 1, shard 2, but a shard is a partition. We can say partition 1, partition 2. So sharding is a partitioning. Sharding is partitioning. And there are many, many ways to do sharding. The most common way is hashed sharding. Okay, so most implementations do this hashed sharding? Great question. Did I answer your question? Was it clear?
Yes, Professor. But sir, Professor, hash sharding is type of bucketing, right?
Right. You need to create a hash function to do that.
Okay, yeah.
So for each of these, you just need to do some configuration or you need to create a function. But generally speaking, the database management systems provide some sharding function. You can do.
Yes.
You don't have to write your own always. Okay, that's what I'm saying.
Okay.
Professor, I
Yeah,
have a doubt. Could you please go back to the previous slide?
sure.
So, Professor, when the application interacts with the shard, so it's the duty of the query router to route it to the appropriate shard based on some logic. Like, how
Right.
would it know from where to fetch?
Yeah, based on the configuration.
Okay.
Actually, it's the responsibility of this driver, right? Because this driver is aware of the entire architecture. The driver knows how many shards there are, right? And also in each shard, what data we have. So usually data like this is metadata or the catalog of a database management system. So it's the driver responsibility to, when the driver get a request from a user or from an application, then the driver will look up some information in the database catalog, in the metadata. Then the driver will figure out, okay, this should go to what query router, and then that query router will route the request to the appropriate storage of the data. So it's the driver's responsibility. The driver sees everything. The query router just sees part of the architecture. Does it make sense?
Yes, Professor. Thank you.
Excellent question. Okay, any other question, please?
Professor, is there any limit as to the shard as to how much data can be assigned for every particular shard?
Technically, theoretically speaking, there is no limit. So as long as we have sufficient resources, and usually we do sharding to get the best performance of the database. So
Okay.
remember, when we do sharding, we have a cluster, right? So in the cluster, you can have as many servers, as many nodes as we need to have. So that's a cluster within the cluster. As long as we have sufficient nodes, sufficient hardware, sufficient resources, then we can have as many shards as we need to have. But that's generally speaking, right? Because when we start to configure our cluster, then we need to configure the distance, the latency, and some other things, the environment, right? So those are all, all factors will determine the best way to do sharding. But generally speaking, theoretically speaking, we can have as many shards as we need to, as we need. We can have as many shards as we need. Any other question? Did I answer your question?
Yes, Professor.
Excellent question. Okay, just keep in mind this driver. This is pretty common. Okay, so even with relational databases, we have, for example, with current version, newer versions of SQL Server, you can do database high availability groups, right? So in a database high availability group, you may have many shards, but we don't say shards because it's more like a replication. So shard is a part of a database, but replica is a copy of a database. But they use the same architecture, the same technique. For example, with SQL Server, the newer version of SQL Server, you can have the database high availability group. Within that high availability group, you have a cluster. In the cluster, you can have, for example, 5 copies of your database, right? Then users and applications will work through the driver. So maybe a different name, but it's something similar to this, a driver. And then that driver will route a user's request and application's request to the appropriate copy of the database. So the architecture is the same. This driver, okay. And now we are talking about sharding, and another similar, I think replication uses the same architecture. Let's look at replication. So MongoDB and all NoSQL databases do replication as well. So we say a MongoDB has 3 copies, right? But now we are talking about a copy of the complete database. We're not talking about a part of a database. We're talking about each of these is a copy of the complete database. So we have a database. For example, this is the main database. Then we make a copy of it to make a secondary database. Another copy, that's a secondary database, and so on and so forth. So this is similar to the replicas in database high availability group. So in SQL Server, we have that database high availability group. Okay, so it's the similar architecture, the same concept. So each of these is a complete copy of a database. But I don't have this in here, but somewhere there is a driver, a router, different names. Okay, so you have a driver, these applications, BI or operation, whatever applications, they will go through the driver or the router, whatever, different names. Then, depending on the configuration and the type of request, the driver will route the request to the appropriate copy. So in this example, we have this primary copy of the database and then several secondary copies of the database. It's always true that write operations, like you want to insert data, you want to delete data, you want to update data in the database, then those write operations are processed by the primary replica. So the router, the driver knows if there is a write request, then it's routed to the primary copy. But if it's a read request, for example, if a reporting application is doing some query to create a report, then it depends on the configuration. Okay, you can say, okay, I want read operations to be processed only by the secondary replicas, the secondary copies. So we can have the primary copy do write operations to get best performance, then that's doable. Okay, in a very busy environment, that's very common. you will have the primary replica do all write operations, but you have secondary replicas do read operations. And generally speaking, there are 3 copies of a database. So the main copy is the primary, and then there are 2 secondary copies, 2 secondary replicas, but that's configurable. Usually there are 3 copies of a database, but you can have more than 3 copies. So if there's a problem with the primary copy, the primary replica, then one of these secondary replicas can be promoted to work as the primary replica. Remember, the primary replica is important, right? Because the primary replica will process write operations, so that's required. So this is replication, and remember, each of these is a complete copy of a database. But when we talk about sharding, right, each of these is just a part of the big database. When we do sharding, we have this driver, right? Sometimes, you know, the terms are used interchangeably. Some vendors call this router, but, you know, some other vendors have more specific terms like, you know, driver and then router, whatever. The concept, the architecture are all the same. To users, to applications, they work through a driver. I think that's probably the most generic term. Applications and the users work through a driver. When they work through the driver, they see just one copy, one database, okay? Whether we do replication or we do sharding. To applications and to users, when they work through the driver, they think they are just working with one server, one database. They don't know what's in the architecture, and they don't need to know, right? All they know is they are working with a database, and that database is hosted on a server. That's all they know. That's all they know. They don't care about other details. But under the surface, there are many different architectures, right? You can do, for example, here you do sharding, and then here you do replication. So replication is for high availability and disaster recovery. And the NoSQL databases do almost all NoSQL databases do replication. Relational databases can do replication as well. For sharding is mostly for performance improvement. All NoSQL databases do sharding. For relational databases, only new relational databases do sharding. Traditional relational databases do not do sharding. Okay, so, you know, there's just a lot of details, right? When you talk about replication, all databases can do replication. I probably should have said all major databases can do replication, whether it's relational, whether it's traditional relational, NewSQL relational, or NoSQL. They can all do replication. But replication is mostly for high availability, data locality, disaster recovery. So that's replication is about making copies of a complete database. But as far as sharding is concerned, sharding is for performance improvement, right? We split a large database into pieces, and then we put each piece on a server, and that those servers make a cluster. So only NoSQL databases and NewSQL databases do sharding. Traditional relational databases do not do sharding. But the architecture, the high level architecture is all about the same, because users and the applications, they will work through a driver. And this can be a different name, right? You know, some vendors use driver, other vendors use router or whatever. Architecture is the same. Whether you do replication, you do sharding, the high level architecture is all the same. Users, applications work with the driver, and then they see just one database, one server, right? But what sharding does is very different than what replication does for us. Sharding, keep in mind, is for performance improvement. Replication is for disaster recovery and high availability or data locality. You cannot use sharding for disaster recovery, right? Because if the database has 10 parts, if 2 parts are lost, then you cannot recover. You have to count on a replication for recovery. Making sense?
Professor, can we use both sharding and the other one for on the same database?
So could you rephrase your question? Can we use sharding to
And the replication,
together?
yes.
Yeah, they are always used together
Okay.
for NoSQL databases, because NoSQL databases do sharding, right? So when you do sharding, you split a big database into pieces. Each piece is a shard, right? So NoSQL databases and NewSQL databases, they all do sharding. So for them, they also do replication. So when they do replication, they will replicate the complete set of shards. So when you, for example, we do sharding here, right? We break up a large database into 10 pieces. Then when you do replication, you have copies of the same database. In each copy, there are 10 pieces, 10 shards. Great question.
Professor, I have one more question in
Sure.
replication. Can you go to the replication slide? Yeah, so is this kind of load balancing, and also yeah, we will write something to the primary database and read from the secondary database. So who will do the data transfer from primary to secondary?
So we're talking about two things here, right? I think number one, I think you mentioned load balancing. Yes, when we do a replication, we can do a load sharing, load balancing, right? So that's your first question. The
Yes.
second question was how do we make sure all these copies are synchronized, right? I think
Yes.
that was your second question.
Yes.
Yes. So usually when we do this, we will ship the transaction log. So a transaction log has all the transactions that has taken place on the primary replica. So for example, on the primary replica, we have write operations, right? You have records inserted, you have records updated, then all of the changes are stored in the transaction log. So depending on your configuration, the transaction logs are shipped from the primary database or primary replica to the secondary replicas. Ship from here to here, ship from here to here, ship from here to here, right?
Mm-hmm.
And depending on the configuration, the refresh interval is configurable. You can say, okay, I'm going to synchronize all these copies every 1/10 of a second, or maybe every 5 minutes, right? It all depends on your configuration, your business requirements. Those things are configurable. A lot of those are configurable.
Okay.
Yeah.
Thank you, Professor.
Great question. And we can talk about this database architectures for quite a while because there's a lot. Okay, but usually if you do data work, you don't really, you are not that much concerned about the architecture. Okay, because when you run your SQL query, when you create your report, you are a developer, you are developing an application. The application reads data from a database. You don't care about the underlying architecture because whether the database does sharding, does replication, it doesn't really make any difference to your code, generally speaking. Okay, your code doesn't care about that. But if you are a production DBA, or you are a cloud environment engineer, you set up the database management system, you do performance tuning for your cloud environment, for your database management systems, you do database administration, then you need to be very familiar with this low-level configuration, low-level details. So I was a production DBA for 2 years in Microsoft cloud computing environment. So I knew there's a lot. Okay, there's a lot. Especially nowadays, people are trying very, very hard just to make an application or a query runs probably 1/10 of a second, maybe half a second faster. So performance is very, very important. So when you talk about performance tuning, when you talk about disaster recovery, when you talk about availability of your data, right? You care about those things. But if you're just a developer, you are a data scientist, you're not concerned about those things because to a software development engineer, to a data scientist, the architecture doesn't make much difference to them. Performance, other than performance, their code will be the same.
Professor, when we are talking about the the reliability and data availability, are there any nodes and clustering in this also, or they're in sharding only?
So can you be more specific? So what we're talking about two things, availability and the sharding, right? Be more specific.
When we are talking about replication,
Right.
is there any clustering and nodes in that as we are seeing in the sharding, because the data is divided into small pieces?
So when we do sharding, we're talking about one database to be broken up into pieces, right? So that's sharding. But when we talk about replication, we have to replicate the entire database. That means all shards of the database will need to be replicated. So they are usually done together.
Okay, Professor.
Did I answer your question?
Yes, Professor.
Yeah. But you think about the situation this way, right? So what we're talking about is just the software architecture, right? Software architecture, the database management system architecture. The underlying environment is the hardware, right? So you always need to do clustering. So there are many different clustering technologies. You always need to do clustering. When you do clustering, you are connect many computers together, right? So in your cluster, you may have 100 computers, 100 servers. you may have just 25. Depending on your configuration, depending on your requirements, then the clustering technology is even more detailed, because when you do a clustering, you have all sorts of protocol, right? You need to check the heartbeat to make sure each server in the cluster is healthy. And then when the cluster comes up, you have all sorts of protocols. For example, a cluster cannot come up unless more than half of the nodes are healthy. More than half of the nodes can come up. But you also need to think about the sharding, right? Because when you make your database available, all shards must be available. If there are 3 copies of a database, if 1 copy is not available, 2 copies are available, that's fine. We can run, right? If we have three replicas, 1 replica is dead, the other 2 are fine, that's fine. We have a complete database that can work. On the other hand, if you have 10 shards for a database, if 1 shard is not available, and that shard is not available for all replicas, then your database is not complete. It will not work. So it's a lot more detailed than what we are talking about. That's what I'm saying. Making sense?
Yes, Professor.
Okay. So we can talk about these things, for a long time, because I was a production DBA. So I'm very familiar with those things. But I think, for this course, our focus is on the data side, right? When you write your application, you are an SDE or you are a data scientist. You use data to do machine learning, to do analytics, or you are data engineering, you do data pipelining. Usually you don't care about the low level details. You don't care about the architecture that much.